Hi guys, today's lesson is going to be on similar polygons. Now, if we take a look, similar polygons are figures that have the same shape, but they're different sizes. If you take a look at these two triangles that I made right here, you notice all the sides are equal. These are all 2, and these are all 8. These are both equilateral triangles, because all the sides are congruent. Now, not only that, we also know that equilateral triangles are also equiangular, so all the angles have to be equal. And we also know that all the angles are 60 degrees. Well, if this triangle is equilateral, and so is this one, that one means that the angles here are also all 60 degrees. So as you can see, the angles that match up are equal. That angle matches with that, that's congruent. Same thing here, and for these as well. But the side measurements are different. This is what similar triangles look like. Okay, similar, anything can be similar. You can have similar quadrilaterals, similar hexagons. You know, any shape can be similar. You can have two shapes that are similar. But in this case, we're looking at some triangles. Okay, so if you take a look right here, this information right here tells us that triangle ABC is similar to, see the little squiggle? That is the symbol for similar. The squiggle without the equal signs, that's the similar symbol. So we're saying that triangle ABC is similar to triangle DEF. Now, that means a couple things. First of all, it means that angle A is congruent to angle D. A and D match. So that angle there is going to match with that angle there. They're both going to be 60 degrees. Angle B matches with E. Same thing. They're both going to be 90. And angle C matches with angle F. They're both going to be 30. Now, these happen to be 30, 60, 90 triangles. So if you take a look, cross from 30, we know that's the short leg. That side was 3 given to us. Short leg times 2 is the hypotenuse. So that side would be 6. Over here, we know that the short leg times root 3 is going to be the long leg, so we can get those 3 sides. Over here, we were given the hypotenuse is 18. We know half of 18 is 9, that's the short leg, and then short leg times root 3 is the long leg. Now, if you take a look, we know that these two triangles are similar because they told us. But not only that, when you match up your sides that go together, this side goes with this side, right? So the 9 and the 3 match. When I create a ratio out of those, 3 over 9, I'm going to reduce that and I get 1/3. I can do that the same with each pair of sides. This side here matches with this here. That's the 3 root 3 matching with the 9 root 3. So I'm going to write a ratio out of that. 3 root 3 with the 9 root 3. I'm going to reduce. So I can reduce that. They cancel out. And the 3, of course, goes into the 9 3 times. And I get 1/3 again. And finally, I have this side here, that is 6, that's AC, matching with this side, DF over here. So the 6 and the 18 go together. And when I make that ratio, I also get 1/3. If you notice, all pairs of sides that match up will reduce to that same scale factor there of 1/3. That's the scale factor, okay? That's the ratio of one figure to the other figure. So let's take a look. Polygons are similar if their vertex points can be matched up so that the corresponding angles, again, all the angles that match up are congruent. Corresponding angles, matching angles are congruent. And the corresponding sides, the sides must be in proportion. Now, what I mean by that in proportion, just to show you a little example of what in proportion here means, is if I took that side, that 3 to 9, and I set that equal to the 6 to 18, if I cross-multiplied those, I would find out that 54 equals 54. And you can see that they're in proportion. One of the ways that we show that things are in proportion is just by simply reducing them to the same scale factor. It's the same thing of showing that they're in proportion. So the sides must reduce to the same scale factor. Okay? That is important. That is the way that we're going to show that the corresponding sides are in proportion. A dilation. A dilation is going to be a transformation that preserves angle measures, and what's going to happen is it's going to result in a figure that has an image with lengths that are proportional to the pre-image. We've already taken a look at dilation. We looked at that before as an enlargement, right? When something grows into a bigger shape. That's our dilation there. Now, similarity ratio. Similarity ratio is basically the ratio of the lengths of a pair of corresponding sides in simplest form. That's what the similarity ratio is. It's a ratio of a pair of corresponding sides in simplest form. Okay? It is also called the scale factor. So when we look at the word similarity ratio, we also can call that the scale factor as well. They mean the same thing. The ratio of the lengths of the corresponding sides of an image and the pre-image is called the scale factor for the dilation. Now, dilations are known as similarity transformations. We also had congruence transformations as well. That was our reflection, translation, rotation. They were our congruence transformations. The dilation is the only one that's the similarity transformation. Let's take a look at this example down here. We have polygon PQRST is similar to, again, there's that little symbol we see right there, polygon VWXYZ. Okay, we know that these two shapes right here are similar. We also know based off this information that angle P and angle V match up. Those two are corresponding angles and they will be congruent. So if this angle here, say, was 80 degrees, this one would also be 80 degrees. So for the definition of similar polygons, we know that the corresponding angles are congruent and the corresponding sides reduce to the same scale factor. This is the key thing that has to happen for all similar polygons. In this particular picture, we can match up a pair of sides. If you can see, PQ, right, that's the first two letters there, is going to match with VW, the first two letters here. Those two sides match. And we can, if we circle those two sides, we can write the scale factor from this. We're going to match up a pair of corresponding sides. And we're going to set them up in a ratio format. So we're going to set that up as 20 over 32, and we're going to reduce that. We can see that 4 goes into both of those numbers. 4 goes into 25 times, 4 goes into 32 8 times, and that is simplest form. A ratio of a pair of corresponding sides in simplest form is called the scale factor. Again, similarity ratio and scale factor mean the same thing. Let's go to the other side. Okay, let's take a look up here. All right, here we see an example. We know it tells us right here that the quadrilaterals are similar to one another. And we also can tell by the order of what matches up. So the A prime angle matches with the A angle. So A matches with A prime. We also know what sides match up as well, right? The first two letters are AB. Those two sides right there, that AB is going to match up with side AB over here. So those two sides will be corresponding sides. All right, we've got to find the scale factor. Now, the way you find the scale factor is you look at the picture and you find a pair of corresponding sides that match up, that both have numbers on them, right? We just looked at these two, right? This pair of side and this pair of sides. They don't both have numbers on them, so we can't use that 20 at all. This side AD matches with this side over here, A prime, D prime. They both have numbers, and once again, I'm sorry, they don't both have numbers. One has number, one doesn't, so we can't use those either. The next pair of sides we get to is this one and this one, right? The D prime, C prime, and the DC. Those two match, again, do not both have numbers. And then finally, we come to the BC and the B prime, C prime. And if you notice, those two sides both have numbers. One is 25, one is 15. Okay, so we're going to match those up. And if you look at this picture here is the little figure. This is telling us that the little figure is similar to the big figure. So we're going to write a ratio there of the little figure over the big figure. Okay, little figure over big figure. This is how we're going to come up with our scale factor there. Little figure over big figure. Okay, so little figure is 15. Over the big figure is 25. But remember, scale factors have to be reduced. So 15 over 25, 5 goes into both, and we get 3/5 as our scale factor. Okay, now we're going to use that scale factor to find missing sides. So now let's take a look at what matches up. So A prime, B prime is over here. We don't have anything on there. I'm going to call that X right now. So the X is going to match with the 20. So I'm going to use the scale factor of 3/5, and I'm going to make that X match with 20. Again, little figure over big figure. So little figure is X over big figure is 20. And now I'm going to cross multiply. Here's where all your proportion work that you practiced is coming into play here. So 5x is equal to 60, and when you solve that, X works out to be 12. So that side right there of X is 12. All right, let's do the next one, AD. AD is this one right here. I'm going to put a different letter on there. I'm just going to put a Y. Now, I'm going to use that scale factor again of 3/5. Now, let's match that up. 12 is from the little figure, Y is from the big figure. We're going to do little figure over big figure. So 12 is from the little, and we have Y from the big. Again, cross multiplying, 3Y equals 60. Our Y value works out to be 20 there. Okay, so we just found 20 for Y. Again, we were looking at this matchup right here, so we got 20 for that. Okay, the next side we have to find is D prime, C prime. This one here, I'm going to put a Z on that one. so that we have this z matching with 30. And again, I'm going to use that scale factor of 3/5. Z is from the little figure, 30 is from the big figure. You want to make sure you're matching them up correctly or you're not going to get the right answer. So when we cross multiply, we get 5z is equal to 90, and z would equal 18. So that is that final missing side there. Now the next question asks you to find the perimeter. Let's see, it wants us to find the perimeter of the big one first. So we are going to add up all of our sides. We have 20, 30, 25, and 20 there. So when you add all of that up, that adds to 95. So the perimeter of the big figure there is 95. And then we're going to do the little one. We're going to add the 12, the 18, the 15, and the other 12 together. And when we add those up, we get 57. So it says find the ratio. And they want the little figure to the big figure. Little over big. Remember, whenever we see that word 2 in there, the first number to the second number. So the first over the second. So 57 over 95. And we're going to reduce that there. And when we reduce that, believe it or not, we're going to end up, and it does reduce, it ends up being 3/5 when you reduce that. Now, what do you notice? What do you notice about the ratio of the perimeters? Take a look. These two numbers are exactly the same. The ratio of the perimeters is always going to be the same as the scale factor. It's always going to be the same as the scale factor. Let's make sure we can read that word. Scale factor. Okay, so these two here will always be the same. And whenever I ask you that question in the future and I say, okay, what's the ratio of the perimeters, you know it is automatically going to be whatever the scale factor was. Okay, let's go to the next problem. Now, in the next problem here, I did some of the work for you already, but let's take a look. We want to find the scale factor of, now this one says ABCD. This time that's the little figure and the primes are the big figure. So we want to set this up. So we've got to find a pair of sides that matches up that both has numbers. So I'm going to start matching things up. All right, those two sides go together, but they do not both have numbers on them. This side over here matches with this side over here. Again, they do not both have numbers on them. This side matches with this side. They do not both have numbers either. And finally, we get to that side that's 12 and that side that's 15. They match. Those are the two sides that both have numbers on them that match up. So I'm going to use those for my scale factor. Again, this is little figure similar to the big figure. So I'm going to set that up as 12 over 15. But I have to reduce that. Okay, scale factors always have to be reduced. So in the end, we're going to get 4/5. We're now going to use that 4/5 to help us find all the missing sides. They wanted us to find BC. If you noticed, I'm going to put BC in for X over there. And I know that the X matches with the 30. So I set it up as 4/5 is equal to X from the little figure over 30 from the big figure. And I cross multiplied. And when I did that, I got 24 for the answer for that side of X. The next one they wanted me to find was this one here. So I'm going to put a Y on that one. That's the A prime, B prime, and I'm going to put a Y there to find that measurement. So again, little figure to big figure. 4 to 5 is the scale factor. 16 is from the little. Y is from the big. So 4 to 5 equals 16 over Y. Again, cross multiply. When we do that, we end up with Y equaling 20. So this one works out to be 20. These two sides went together. And finally, I need to find this side right here. I called that side Z, just a different letter, and I know that that matches with my 40. So I use my scale factor of 4/5, and I set Z from the little figure over 40 from the big figure. So Z from the little over 40 from the big, and I cross multiplied. And when I did that, I ended up with Z equaling 32. So this one worked out to be 32. And then I had to find, oh, actually, don't miss this question right here. This is an important one. What is the measure of angle D prime? Now remember something. This tells you all the letters that goes together. We know angle A matches with angle B. We know that D matches with D prime. Now D has a 90 on it, which means D prime is also going to be 90. So that angle right there is going to be 90 degrees because all the corresponding angles that match up are congruent to each other for similar polygons. All right, now we're going to find perimeters. Perimeter of the little one, I added up all the sides and I got 84. Perimeter of the big one, added up all the sides and I got 105. When I reduce those, okay, when I reduce those, I am going to get 4/5 in simplified form, which again, we already know when we set that ratio up of our perimeters, we already knew what that answer was going to be. We knew it had to be the same exact answer as this. Remember, these two here are the same. The ratio of the perimeters is always the same as the scale factor there. All right, let's look at the last two questions here. Okay, so when to determine if the polygons are similar, if so, write the similarity ratio and a similarity statement. So here's the way we do this. Okay, we're going to try to determine if these two triangles are similar. It's not telling us they're similar right here. There's no similar symbol in between. We don't even know if these letters go together right now because there's no similar symbol. We're trying to figure out. The way to do this is to match the smallest side with the smallest side. So if I look at this here, my smallest side is, let's see, 10. And my smallest side over here is 15. So I'm going to match up 10 over 15, and I'm going to reduce it. And when I reduce that, I get 2/3. Okay? Then I'm going to match up the two biggest sides. Let's see, well, it doesn't matter. I can next smallest with next smallest, or I could do the two biggest. It doesn't matter. The two biggest, I have, let's see, 17 and 25.5 there. 17 and 25.5. Now that one doesn't reduce real great, right? I can't really reduce that as a fraction, but I could divide it. Remember, this ratio here is in fraction form, but could also be written in a decimal form. And when I divide that, I'm going to get 0.66 repeating. Well, if I take 17 divided by 25.5, I am also going to get 0.66 repeating. So believe it or not, they are both 2/3. And then finally, I got to match my last pair of sides up because you have to check all pairs that match. 12 over 18, that will reduce to 2/3, which again is 0.66 repeating. So all of these work out to be the same thing. So are the triangles similar? Yes. Triangles are similar. Triangles similar. The scale factor there is 2/3. And then it asks you not only to write the scale factor, right? That's the similarity ratio. That's your scale factor there. They also want you to write a similarity statement. Similarity statements are like this right here. We have to write the similarity statement. We're going to match things up ourselves. So this is a very important piece right here. I'm going to match up the letters. Now, again, remember what I said. Smallest with smallest. But what I do is I look for the two smallest sides, right? And I find where that angle meets. They meet at F. So F is going to match with the two smallest over here. The two smallest here, let's see, is the 18 and 15, and they match with J. So F and J match. Then what I always do is I always go to where the two biggest sides meet. So that here would be the 17 and the 12. They meet at G. So G is my next letter. And my two biggest here are 25.5 and 18. So they meet at K. So that means G matches with K. And that only leaves one pair of angles. So that means that the E has to match with the H. Okay? And that is a very important piece right there. That is your similarity statement. Yes, all of this is your answer, but that similarity statement there is a very important part of the answer. Let's go to the next one. The next one's a rectangle. And rectangles have opposite sides congruent. So if this is 24, that side's going to be 24. And if this is 15, this side is going to be 15. And likewise, we can do the same thing over here. Opposite sides are equal. That's 8, and of course, this would be 5. So now I'm going to match up my corresponding sides. And when I do that, I can see that the 8 and the 24 match. So I'm going to do little figure over big figure there. 8 and 24 reduces to 1/3, but I have another 8 and 24. So both of those, of course, will be the exact same thing. They will both reduce to 1/3. And then I have my other two pairs of sides, which is my 5 over 15. Again, reduces to 1/3, and I have two pairs of those. So all the sides, that's 4 pairs of sides, all match up and reduce to the same scale factor of 1/3. So, yes, my rectangles are similar. Okay, that's what that means. They're similar. My scale factor there is 1/3. And we need to write that similarity statement. Now, this is a rectangle, right? I need to draw that as a better rectangle. All right, so the rectangle there is, we're going to match up letters. I'm just going to go around the figure. X, U, V, W is similar to rectangle. And again, I'm just going to match up R, S, T, Q. R, S, T, Q. All right, and so there we have our similarity statement, and all of this is our answer for that problem. If you're having any trouble with any of this, go back and rewatch the video. Okay, guys, good luck.